Without further ado, I'll give over to Christoph, co-founder of Etherisc, and Christoph, you take it. Thank you.
Thank you, Stefan. So now we are coming to a story which is at the very heart of what Etherisc is doing, building protocols for decentralized insurance. And I must admit, we are not at the end of the story, but maybe at the second line of the story, which is going to be a long story. And I'm just giving you an impression on the status what we are working on. And to begin with, I just want to lose some words on what is a protocol. Basically, well, this is Angela Merkel, and the other women is also very well known. So why do they need such protocols? This is a classical situation for a formal protocol, the greetings and so on. They need a protocol because it enables communication. Yeah? Angela Merkel and the Queen would have a hard time to communicate if there weren't such protocols. So the one thing is protocols enable communication between partners which don't know each other, because they know the rules of the game and they know how to interpret the different parts of their communication. So this is why we have protocols. The other thing is also a very well-known event. You see here, this guy is Mr. Sullenberger. He managed to land Boeing on the Hudson River. And what is the connection to protocols? Well, that he was able to land the jet on the Hudson River is due to established security protocols in the cockpit. So in the second after he realized that there had been birds in his engines, in the second after he realized it, it was completely clear for everybody of the staff who is in command. And it was Captain Sullenberger. And the whole procedure from informing the tower and all the relevant authorities on what is going on, it was all engineered by protocols, and these protocols had been trained again and again and again, and so this was the survival of all these people, that there had been protocols. So we need protocols, and now protocols ensure communication, so they make it that the communications are safe, that they are unambiguous, and that everybody can use it. And so it's an interesting question, what are properties of good protocols? I think I have looked in Google for definitions of good protocols, and basically it's hard to find good works on this. So I tried myself, and I found 5 aspects of protocols to be good protocols. First of all, a protocol should be minimal. It should not have overhead. It should be condensed to the absolute minimum which is needed to enable the communication. On the other side, and this seems to be contradictory, it should be complete. If there are missing parts, then what do you do? Yeah, then you have to go outside the protocol, and then you break the protocol. Basically, think of the internet. If you want to send an email and you need some paperwork to accompany every email, then this would break email. So email protocol has to be completed. It must cover every aspect of email. The next thing, it must be robust, it must be stable against errors of every participant, and if there are errors or mistakes, then the protocol should be able to react, and to re-establish the communication, it should be layered, so it should have different layers of complexity from the lowest level to the highest level. And of course, it should be accepted by all the participants. A protocol which is not accepted is basically useless. So these are, for me, 5 aspects of good protocols which we try to establish in our decentralized insurance protocol, which we are going to develop. So now I would like to show you the implementation of all these aspects in our protocol. We are starting our protocol from, as I said, we have a layered protocol. We are starting from a very low level, which is basically the Ethereum client implementation. This is the basic of blockchain, the core functionality of blockchain. And on top of this, we have the EVM, the Ethereum virtual machine, which executes code on the blockchain, which ensures that the contracts are executed. And so this is also, it's still very low level, and everybody knows this, and there is no special business connected with this. And on the next stage, we have higher order languages. This is also already, I have put it a bit higher than the rest, with a certain gap in between, because there is no mandatory connection between the higher order language, like Solidity, Viper, Haskell, or whatever, to the underlying EVM. Basically, everybody could build a higher order language on top of the EVM on itself. If you have the skills, then go ahead. It's not easy, but as you see, for example, Vitalik is just working on Viper to establish a secure standard for smart contracts, and the most used higher order language is Solidity. So this is still a very common standard, but it's independent on the underlying. Then the next step would be the coding best practices. You have seen Sebastian, who is working on the standards. You have seen Fabian Vogelsteller, who developed the ERC20 standard for tokens, which is very famous now. And of course, you have some libraries like SafeMath, which enables you to do a safe, to use some safe practices if you are programming smart contracts. So this is completely independent of business. And now I think there is a gap again, because now we are coming in the business world. Now we are starting to enter a world where we have entities and where we have notions which are from the business world. And the deepest notions which we are having here are the notions of business processes. The business process is basically a sequence of steps to perform a certain business task, and these processes have been in place at all times, but studied only in the recent years, and still younger are the standards for this. For example, we have the BPMN 2.0 standard for describing and modeling business processes. And we don't see such engines on the blockchain, but we at Etherisc are planning to establish such a standard on top of these basic technical layers, because we think business processes have much in common, and business processes basically don't know any borders between businesses. So you have banking, you have supply chain, you have insurance, and all these processes are linked together. So if everything should work fine together, then you need a common language for business processes, and we don't want to reinvent the wheel. We want to go on top of all the research which has been done in the last years, and very important research has been done on the business process side. And so one of our goals for the next year is to build a business process engine on top of the Ethereum blockchain, which enables many to build safe processes, and which is reusable, which is verifiable. Maybe we can formally verify such a business process engine, and then we have a very secure and safe basis to build our processes. But still, we are not yet in the financial area. So we are basically in a very generic area. Everybody can use our business processes. And as the next step, now we have financial atomic processes and standards. For example, payments, assets, identity and data storage for financial processes. This is the first time where we see the word financial. And there we have the notion of KYC, identity, governance, and all this. And we think we can establish standards for this. there are many people working on this, and I will come a bit later to an important aspect of Etherisc. We are not trying to do everything on ourselves, but we are trying to get people working together and putting their work forces together to build such a standard. And the last thing, now we are coming to the different financial industries, insurance, banking, and so on. And of course, we are mostly working in insurance, but also we have close connections to banking, because at some time we'll have funds, we have to manage these funds, and then we are in the area of banking, of fund management and others. And of course, then there will be also individual companies which build their extensions on top of these standards, which are maybe even proprietary and special for a certain product or business. So this is the idea of a business protocol stack which we will build, and for sure we will not build everything on ourselves, but we will try to collect the best practices of all the projects in the space and try to combine them to a common standard. And I see much work on this. Maybe somebody has read on Fabian Vogelsteller's last work, the identity standard, which tries to build a standard for identity and claims. And I'm very interested to incorporate this here in this picture. Okay, now how does this apply to our first example, flight delay? This is basically the architecture of flight delay, and as you can see, we have already also these stacks. We have a very low-level stack or low-level layer here. The low-level layer is, in our case, a controller contract, which registers contracts, which controls the interaction of smart contracts. We have a system of, at the moment, of 7 independent smart contracts, which together form the flight delay smart contract application. On the next layer, we have still very generic contracts which store funds, which accumulate all the data, and which control the different access of contracts to each other. And on the top layer, there we have this business layer. Yeah? This is a business layer with very similar to what Matt is thinking of. We have generic contracts for new policy, for underwriting and for payout. And this whole system is basically independent on the actual insurance product. So you could build a crop insurance, you could build a flight delay, you could build a crypto wallet insurance, whatever, with this generic system of smart contracts. And interesting thing, this whole thing is also completely independent on the front end. Basically, everybody can build a front end to our insurance, and actually people are working on this. We have, for example, Status. The Status guys, they are building a messenger platform, and they were looking for interesting applications of the messenger platform. So they sponsored a team in the Netherlands, and this team built a mobile app for our flight delay insurance, which maybe will be hopefully live in the next days. Don't know. So everybody can build front ends for us, and of course we have built a web front end for this. We also have a mobile-able front end for this, and this is a nice feature of this architecture, that the different layers are more or less independent of each other. So it's very flexible, people can adapt it, and so this is an open framework and not a closed shop. The interaction of these is very structured. We have only one single point of contact to the real world, which is the interface to the new policy. So every front end will interact with this same interface, and so the attack vector for the whole system is very small. All other contracts only interact with each other. We have, of course, Oraclize, Thomas, which we are using for a year now, and it's very reliable. And basically the underwrite and payout contracts talk to Oraclize, and via Oraclize to our data provider. And so they get knowledge on the outer world via Oraclize. And the communication between the contracts is made via certain buses. So we have a framework bus here, this is the blue lines, which connects all the technical architecture with each other, and we have a business bus which connects the generic insurance contracts with the specific models of flight delay, which is a risk model and a validation framework for our concrete product, which is flight delay. So we basically can isolate the whole specific product logic in one single smart contract, and everything else is very generic. To admit, the current version which you can see on the blockchain is still not in this model. We have still the logic, the business logic of the concrete product distributed here in these three contracts. But in the next version, which we aim to deploy for our next pilot for the Token Summit in San Francisco, we'll already have this isolated business logic. And this is very nice architecture because it enables us to exchange the parts of the system. If there is an error in any contract, then we can flexibly exchange it. For example, we had a bug in the payout contract, and but we had already sold some contracts, but the data of the contract is stored here in the database, so we could exchange the payout contract by the next version without affecting the rest of the system. So maybe someone will ask, well, this violates the holy grail of immutability on blockchain. So we have a certain idea of this. We think as soon as you have a state on a blockchain, then immutability is only relative, yeah? Because of course you will change data, and if you can change data, then you can also exchange the logic. But what is the value which we keep? The value which we keep is the transparency and the fairness of the whole system, because basically everybody who makes a policy on this system always knows to what system he is talking. And if we exchange a contract by an upgrade, then everybody can see this and can validate this and can see if we are doing anything bad there. And of course we are not doing anything bad, but we are trying to keep the customer experience high. And if there is a bug, then this is for sure something which all customers want to be fixed. So this feature is, I think, a very important thing which we have implemented here. Okay, now we have many solutions already, but of course we have also many challenges. Thomas already mentioned many of them. We have, for example, the challenge of complex computations, and Oraclize and others are offering also some concepts how to solve this. If we are going to have more complicated risk models, we have of course the problem of big data storage. Maybe we sometimes have to store images, we have to store big data on the blockchain, and this is a problem, but also there are some concepts and solutions for this. We have the topic of privacy. Nobody wants his personal data visibly on the blockchain, but also some concepts are coming up, and I'm very interested in the next talks, in the next days here on DevCon, which there are, I think, at least 5 talks on this topic of zero knowledge proofs, which will gain a very important impact on blockchain technology as a whole. Scalability is an issue, of course. We are all waiting on Casper and sharding. We have identity solutions which we need, also many projects working on them, and last but not least the costs. If you do it wrong, then you can pay hundreds of dollars for deploying a single contract. We also did this mistake, so you have to keep an eye on the gas costs. But if you look at the Ethereum gas station, then you see gas costs are manageable and are also decreasing. So I think the topic of transaction fees is something which is very interesting for us, but I'm very confident that we find good solutions in the next months and years. Okay, now we have a protocol, and how is the road to adoption? A protocol which is not used is useless, basically. So the road is difficult, and we think we need many people to come to this goal. And adoption of a protocol is an emergent process. So what is emergent? Emergent is something like this. Yeah, you have a simple pattern. This is game of life, a famous mathematical model invented by I think John Conway. And you see there is a very simple rule. The game has only two rules. And these rules manage the whole process of these little dots which represent cells. And you can see these simple rules, only two rules, lead to a very complex pattern. And this is emergent pattern. And the adoption of a protocol is something similar. Yeah? You start with something very simple, and then you see one guy, two guys, three guys, like we started 1 year ago, and now we have a room full of people who are interested in decentralized insurance. I never expected this. For me, this is a great day today, because it proves that we have met obviously something similar. A very simple idea which is attracting many people, and this can lead to adoption of our upcoming protocol. Yeah, and this protocol will be a work of many. This will not be built from Etherisc, it will not be built from a single company, it will be a work of many which are working together, which are joining forces. And well, I'm coming, my professional career, I started in the German cooperative sector, and of course I'm a bit biased in this direction. I know how things work in cooperative, and together you can build things which a single one cannot achieve. And I hope that all in this room, or many of these, are interested in working together on this and building a big platform which can be used by everybody, and so we can change this industry, which is important. We have heard from, I think, Charlotte, that in most developed countries, insurance is about 10% of the GDP, which is huge, and this industry is 100 or some 100 years old, and to change it, it needs combined forces of many, and I think we have the opportunity to do so. So you are all invited to do so, and of course there are many opportunities to do so. For example, we are participating as in the jury of the blockchain competition, which has, I think, 80 participants, and many projects are working here. And so I think there is a big future waiting for us, and I hope you all and we are part of it. And yeah, thank you very much.